Hey everyone, Kevin back with a short video. We are going to balance this fairly complicated chemical equation that you see here on screen. If you look at this chemical equation, you'll see that we have 1 as the coefficient in front of each of the formula units that are shown here. And so we have to balance this. What I did is created a little spreadsheet, and the spreadsheet shows to the left of the arrow are 2 species, that carbohydrate, or let's see, C3H7NO2, not a carbohydrate, amino acid probably, and oxygen, O2. To the right of the arrow is carbon dioxide, H2O, and N2. I dropped in the coefficients 1 all the way across because we don't show coefficients in front of this equation, and that means each of the coefficients is 1. If it's not shown, it just means it's 1. So if my coefficient is 1, for example, for that first C3H7NO2, then it means I have 3 carbons, right? 3 carbons times 1. I have 7 hydrogens times 1, 7 in the formula, times 1, 1 nitrogen and 2 oxygens. In oxygen, the coefficient's 1, so I have 2 oxygens. So the total on the left of the arrow is 3, 7, 1, and 4 for carbon, hydrogen, nitrogen, and oxygen, respectively. To the right of the arrow, again, I've got 1 as the coefficient. So in CO2, if there's just 1 CO2 molecule, there's just 1 carbon, but there are 2 oxygens. If water there's just 1 water molecule, there are 2 hydrogens and 1 oxygen. And similarly with nitrogen, there are 2 nitrogens. And you can see the totals on the right side of the arrow. So we want to make these totals the same as one another. So I can just change this spreadsheet and start playing with my coefficients. Remember, we never change the subscripts because that would change the actual identity of the molecule. But we can change the coefficients. So we will, let's see, I will start with N2 because N2 is relatively easy, right? We have 2 on the right of the arrow. We have 1 nitrogen on the left of the arrow. So to make those match up, at a minimum, I've got to change the coefficient for C3H7NO2 to 2. And now my nitrogens on the left and the right are equal to one another. All right, so we're good there. Let's look at oxygen next. We've got 6 on the left side and only 3 on the right side. So we are going to have to increase our numbers. So we could increase CO2 or we could increase H2O. Well, when I'm thinking about CO2, I recognize that if I change the coefficient to change the oxygen, I'm also going to change the carbon. So let's go back and do the carbon first. We've got 6 carbons on the left and 1 on the right. So to make that super easy, we could just change the CO2 to 6. So let's do that. Now we've got 6 carbons on the left and the right. What did that do to oxygens? Well, now we have 13 oxygens, so that's a little screwy. Let's look at hydrogens. So hydrogens, we got 14 on the left and 2 on the right. Well, to fix that, we could bump H2O up to 7, coefficient to 7. So see my change right there. I changed the coefficient to 7. It makes the total hydrogens 14, and now they're balanced on both sides. So hydrogens agree, carbons agree, and nitrogens agree, so that's all good. Oxygens, however, are way off. So now we have 19 on the right and only 6 on the left. Well, we can certainly get those closer by increasing the O2 on the left. So let's increase the coefficient there. We need another 13 oxygen, so we have to increase it by at least 6. Let's try 7. And that gets us within 1, but still we're not in balance. All right, so let's go with 1 more oxygen on the right by changing water to 8. And then if we add 1 more O2 on the left by changing the coefficient of 7 to 8, Well, now our oxygen's balanced, so that's great. But and nitrogens are good, carbons are good, but our hydrogens are off now. We're short on the left. So let's see, what could we do? Well, we could lower the waters to 7. Let's try that again. But now we're back to the same problem where we have an odd number of oxygens. So that's not really going to work. So let's go back to 8 oxygens. So now, if we have to keep 16 hydrogens on the right of the arrow, because we have to have 8 waters, so oxygen is an even number, we need to change the hydrogens on the left. Okay, so if we're going to do that, we could change the coefficient of C3H7NO2 to 3. Let's try that. Well, now we get an odd number of hydrogens, and that's a little tough to reconcile. So let's go to 4. All right, now we've got 28 hydrogens. All right, so we're working on hydrogens. Let's see if we can get the hydrogens in balance. We, of course, can if we go to 17. Oops, I'm sorry. If we go to 14 waters. Now we've got 28 hydrogens on the left and the right. All right, but now nothing else balances. Well, nitrogens now have 4 on the left, but we can easily correct that by changing the N2 on the right. Change that coefficient to 2. Now hydrogens are in balance. Let's see, oxygens, we've got 24 and 26. So we can increase O2 up to 9 on the left. That gets our oxygens at 26 on the left and the right. So the only problem we're left with is carbon. So the only way to increase carbon on the right is to increase the number of CO2. So if we go to 12, that gets carbon right in balance. But what else does it affect? It affects oxygens. So now we have a whole lot of oxygens, 38 on the right, 26 on the left. But we can correct oxygens on the left relatively easy. We just change the coefficient of O2. So let's go to 15 O2, and now we have 38 oxygens on the left and on the right. Excellent. And we've got carbons, 12 and 12, hydrogens, 28, 28, and nitrogens, 4 and 4. So our coefficients are very different, right? We started with 1, but when we balance this equation, we have 4 C3H7NO2 molecules, 15 O2s, those are both on the left. On the right of the arrow, we have 12 carbon dioxides, 14 waters, and 2 nitrogens. Now, I want to have my coefficients be as low as possible. Can I go any lower? If they were all even, I might divide them all by 2 and see how that works. But with an odd number for oxygen on the left, I don't think I can do that. So I believe these are the correct coefficients. Thanks for watching, and I'll see you back in class.